Alright, so welcome. We are starting Chapter 7, Section 7.1, which is all about exponential equations. Okay, and so we have a foldable here that I'm going to fill in throughout this video to help you get through 7.1. Please feel free to look at this foldable in your class notebook, OneNote class notebook, and it'll be filled in there as well. Okay, so exponential equations have a variable in the exponent. Okay, we can solve these equations by rewriting both sides of the equation with a common base. Okay, all right. So let's keep in mind when we're talking about exponential equations, we're talking about a variable in the exponent. Okay, so it'll look similar to that. My base happens to be here, and right now they are not common. Okay, so here in a minute we will make sure that they are common to be able to solve this. And that right there is my exponent. So x right now happens to be my exponent. Okay, so before we get to this as far as finding a common base and solving for this, let's do a little bit of practice here, converting all these to base 2. Alright, so we're first going to start off with 32. So 2 to the what power is 32? Well, over here, let's see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Okay, so all I need to do now is count my 2's. So 1, 2, 3, 4, and 5. So 2 to the 5th power is 32. Alright, next one. 4 to the x power. Okay, so we're talking about 4 to the x power. 2 to the what power is 4? Well, that's 2 squared. Because again, if I look up here, what we did up here above, 2 times 2 is 4. So 2 squared is 4. But let's not forget about that x. Okay. And so when we have an exponent taken to another, a power taken to a power, we have to multiply those. Alright, so we get an answer of here, 2 to the power of 2x. Okay, I'm just going to put those together, 2 times x. Alright, next one down, 16 to the 2x power. Alright, 2 to the what power is 16? Again, I go right back up here. How many 2's did it take us to get to 16? 1, 2, 3, and 4. So 2 to the 4th power is 16. But let's not forget it already had a power there, 2x. This time we're going to have to do 4 times 2x to get an answer of 2 to the 8x power. So that will be my answer, 2 to the 8x power. Remember, we're writing all these to base 2. Okay, we're changing all these to base 2, so all of them should have a base of 2. Okay. Alright, next one, 1/8. Now, this time we are going to have to take the reciprocal. The reciprocal here, okay? So 1/8. And to be able to flip that, to take the reciprocal of it, okay, I'm going to use, I'm going to use a negative exponent. So by flipping that, it makes it 8 to the negative 1 power. Now I can convert it to a base of 2. So 2 to the what power is 8? Again, go back up here. How many 2's did it take me to get to 8? I believe that was 3. Don't forget, we still have that negative 1. So I need to do something with this 3 and this negative 1, which would be to multiply it. So my answer is 2 to the negative 3 power. Alright, one more. Kind of running out of room down at the bottom, so I'm going to just do this right here to the side here. Okay. First off, I see a fraction. So what I'm going to do is I'm going to go ahead and get rid of that fraction. Okay. So 4 to the negative 1 power to the 2x power. Okay. What am I going to do with that negative 1 and that 2x? Multiply them. So that'll give me 4 to the negative 2x power. Okay. We still need to convert this to a base of 2. How many 2's gives me 4? I believe, what, 2, right? 2 squared is 4. And then don't forget about that negative 2x. That just has to move over. Alright. We're going to have to multiply one more time. 2 times negative 2x. That's going to give me a final answer of 2 to the negative 4x power. Here we go. So that one was a little bit more complicated because we had to get rid of the fraction first and then still convert it to a base of 2. Now, we could have went ahead and converted it to a base of 2 first and then flipped it, but it would have came out the same exact answer. Alright, steps for solving equations. Number 1, we're going to rewrite both sides of the equation with a common base. Okay, very important, common base. Both sides of the equation has to have a common base. Set the exponents on each side equal to one another. Okay, sometimes we call this equate the powers. Number 3, we're going to solve the equation, and then number 4, of course, check your answer. Probably the most important step right here, check your answer, because it's most often the most skipped step here in these. Alright, so I'm going to move this down a little bit so we can get down to some of these problems, okay? Alright, so we have 8 to the x power equals 4. So what is a common base for 8 and 4? Well, we saw this just a little while ago. My common base would be 2. So how many 2's make 8? That would be 2 to the third power. Now don't forget to bring down that x equals 2 to the what power gives me 4? 2. Okay. Alright, so first off we have to go and take care of this so we can get rid of those parentheses. So we have 2 to the 3x power equals 2 squared. At this point, step number 2, I can equate the powers. Okay, so I can cancel those bases. We're going to bring down the powers. Then we're going to solve this resulting equation. Okay, so I'm going to divide both sides by 3. So what does x equal? X looks like it equals 2/3. 2/3. Alright, now to do a quick check, let me do it in a different color here. Alright, we're going to replace x with 2/3. So we have 8 to the 2/3 power equals 4. Now, we do have to remember when we have a fractional exponent what each part is, okay? So the top number is my power, and the bottom number is my root, okay? So I could rewrite this here as the cube root of 8 squared, which equals 4, okay? Now, 8 squared would be 64. So if I take the cube root of 64, which I could punch in my calculator, I'll notice that 4 equals 4. So this check works, which means my answer must be correct. Alright, let's just work our way down here, okay? So we have 27 to the x power equals 1 over 81. So anytime you see a fraction, let's go ahead and take the reciprocal and get rid of that fraction, okay? So we have 27 to the x power equals 81 to the negative 1 power. Remember, we're going to flip this. Anytime we flip it, we're going to have a negative exponent, okay? Now I need to come up with a common base. Common base. The most missed step on this one is that a lot of people will say 9. And I understand you can do 9 squared to get 81, but you can't take 9 to a certain power to get 27. So you have to be really careful. Remember, you have to have a common base on both sides. Alright, so let's go with 3. Let's go with something a little bit smaller. Alright, so 3 to the what power is 27? 3 cubed. Don't forget to bring down the x. And, ooh, this one's a little bit harder. 3 to the what power is 81? That would be 4. 3 to the 4th power. Okay, so if I take that 27 and I multiply it by 3 one more time, I get 81. Alright, let's take care of both the exponents there. So 3 to the 3x power equals 3 to the negative 4 power. Now we can cross out our bases since they are the same, and we get 3x equals negative 4. Now at this point, now we're just going to solve for x. So divide both sides by 3. We get x equals negative 4 thirds. Alright, now let's see if that works. Very important to make sure that it works, okay? This time I'm going to do the check over here to the right-hand side, okay? So 27 to the negative 4 thirds power equals 1 over 81. Alright, again, I could rewrite that because the top number is my power, the bottom number is my root, okay? So we have the cube root of 27 to the negative 4 power equals 1 over 81. Okay. Now, it might have been easier just to go ahead and get rid of that negative sign. In fact, I'm going to back up just a hair. Okay, and I'm going to go ahead and get rid of that negative sign so that way I don't throw anybody off. Okay, so what I'm talking about is I'm talking about this specifically right there, that negative sign. Okay, so I can do the opposite. I can flip this as well. All right, so I'm going to go ahead and flip this. So it'll be 1 over 27 to the 4 thirds power equals 1 over 81. Alright, so now this might make a little bit more sense because we do 1 over the cube root of 27 to the 4th power equals 1 over 81. Now at this point I'd go ahead and just punch this in your calculator to make sure that it works. I'm going to pick up my calculator here real quick just to double check it. Alright, so I'm going to do the cube root. Let's see. The cube root of 27 to the 4th power. And guess what? I came out to 81. So that means this checks, which means my answer is correct. Alright, so far so good. Next one down here. Okay. We have 5 to the 3x power equals 1 over 125. Again, I see that fraction right there. Let's get rid of it. Okay. So we have 5 to the 3x power equals 125 to the negative 1 power. Alright, now we already have 5 over here, so and we can't go any smaller than that. So let's see if we can do 5 to a certain power to get 125. 5 to the 3x power equals 5 cubed to the negative 1 power. Okay, notice this 125 is just becoming 5 cubed. Okay, 5 cubed is still 125. Alright, let's take care of that 3 and that negative 1. So 5 to the 3x power equals 5 to the negative 3 power. At this point, we can cancel out the common bases. We get 3x equals negative 3. Divide both sides by 3. X equals, looks like negative 1. Alright, let's double check this. Okay, I'm going to go back to my green pen here. 5 to the power of 3 times negative 1 equals 1 over 125. 3 times negative 1, that'd be 5 to the negative 3 power equals 1 over 125. Let's see, let's get rid of that negative. So 1 over 5 cubed equals 1 over 125. Okay. Again, I was just getting rid of that negative sign. Okay. And we already know 5 cubed is 125, so that means that this checks. And my answer has to be -1. All right. Let's keep going. We have 3 more here. Okay. All right, so this next one on the right-hand side of the photable, we have 3 to the power of 1 minus 2x equals 243. So again, I have 3. I can't go any smaller than 3, but I need to see, can I do 3 to a certain power to get 243? All right, so again, this side is going to stay exactly the same. Equals 3 to the what power? We already know 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3 is 243. There we go. Count our 3's. 1, 2, 3, 4, and 5. Okay, so that would be 3 to the 5th power. Cross out my common bases. Now, keep in mind, you cannot cross out those bases unless they are common. Okay, so please make sure they are common. 1 minus 2x equals 5. Subtract 1 from both sides. Negative 2x equals 4. Divide both sides by negative 2. X equals negative 2 or positive 2? That would be negative 2. Last but not least, we have a quick check to do. Alright, so 3 to the power of 1 minus 2 times negative 2 equals 243. 2 times negative 2 happens to be negative 4, right? Equals 243. And we see right here, what happens with that right there? It becomes plus. So 1 plus 4 is 5. So 3 to the 5th power is 243. Is that a true statement? I believe so, because I think we found it right there, didn't we? 3 to the 5th was 243, so that means it checks, which means my answer must be x equals negative 2. Alright, next one down here. 9 to the 2x. 9 to the 2x minus 5 power equals 27. Alright, so 9 can go down to 3, but can I do 9 to a certain power to get 27? And that would definitely be a no right now. Okay, so let's convert this to 3 squared. 3 squared is 9, but don't forget to bring down that 2x minus 5 equals 3 to the what power is 27? That'd be 3 cubed. Alright, now, to be able to take care of this, we have to distribute. So we have to do 2 times 2x and 2 times negative 5. Okay? Very important. Whenever you have a single digit and then you have a binomial there, you have to distribute that. Okay, so this is going to give me 3 to the 4x minus 10 power equals 3 cubed. Now, I'm not exactly sure why I put parentheses here. I just did, but it was really unnecessary. Alright, so now I'm going to cross out the 3's, and we get 4x minus 10 equals 3. Alright, looks like I'm going to add 10 to both sides first. And we get 4x equals, looks like 13. Divide both sides by. And we get x equals 13 over 4, which is really kind of weird looking, isn't it? It's kind of an odd answer here, okay? So again, what we're going to do is we're going to go right back to our original. 9 to the power of 2 times 13 fourths minus 5 equals 27. Alright, so let's see. I need to put that 2 over 1, so I can do numerator times numerator, denominator times denominator. So 9 to the power of 26 over 4 minus 5 equals 27. Okay. I know how much y'all love fractions. We're going to have to convert that 5. Right now it's 5 over 1, and it needs to have a denominator of 4. So we have 20 over 4. So 9 to the power of 26 over 4 minus 20 over 4 equals 27. Okay, so all I did was convert that 5 over 1 to make sure it has a denominator of 4, because again, to be able to add or subtract fractions, they must have common denominators. Alright, so this gives me 9 to the power of 6 fourths equals 27. I believe that 6 fourths reduces. They're both even, so that's 3, and that's 2. Don't forget that's still 3 over 2. Now, last step here, we need to do the square root of 9 cubed, which we hope is going to equal 27. Okay? Because again, the top number is the power, the bottom number is the root. So I'm picking up my calculator here, and let's see, I'm doing the square root of 9 cubed, and that comes out exactly to 27, which means our check is good, which means our answer, x equals 13 over 4, is correct. Alright, one more, guys. One more. Alright, so we have 5 here. 5 to the power of 3x minus 8 equals 25 to the 2x. Okay, so my common base looks like it would be 5. So 5 to the power of 3x minus 8 equals 5 squared to the power of 2x. And don't forget to combine these. So 2 times 2x. 2 times 2x, I believe, gives us 4x. Do we have common bases? Yes, we do. We can cross those out. Set our powers equal to each other. Now we're just going to solve for x. So I'm going to go ahead and subtract 3x, since I see x's on both sides. We get negative 8 equals x. Yeah, just 1x. So x equals negative 8. Okay, all we need to do now is check it to make sure that it does check. So again, we go back to the original. 5 to the power of 3 times negative 8 minus 8 equals 25 to the 2 times negative 8. Alright, so 3 times negative 8, I believe that's negative 24 minus 8 equals 25. Now this is multiplying out here. 2 times negative 8, that would be negative 16. Alright, negative 24 minus 8, that would be negative 32 equals 25 to the negative 16. And I always get a question here about why do they not look quite equal? Well, if we took it one step further, 5 to the negative 32 equals 5 squared to the negative 16. What would you do with the 2 and the negative 16? You would multiply them, and it would look exactly like that number right there, because we have 5 and we have 5. So that means my answer is correct. Alright, don't forget to do your checks. The only problem that we didn't do in here that you will see in Hawks is you will see a quadratic exponent, which means you could possibly have 2 answers. But make sure you check both answers to make sure that they work. Okay? If you run into any problems, feel free to send me an email. A screenshot is perfect with the letters IDK in the subject line, and that's all you have to put and hit send. And I will work as many examples as you guys